Welcome.
Good day to each and everyone. My name is Jobertilio Campo Jr. I am the last reporter for the module 7. So let me discuss to you my topic, and it's all about complex numbers. So the definition of complex numbers: so any numbers in form e plus bi, where e and b are real numbers and I is the imaginary unit. So imaginary unit, so I is equal to the square root of -1, and therefore I to the power of 2 is equal to -1. Note that -1 is also a square root of -1. Definition of pure imaginary numbers: so any positive real numbers b, so the square root of -b to the power of 2, so we have to factor it or split it, so it becomes the square root of b to the power of 2 times the square root of -1. So the answer is bi, where I is the imaginary unit and bi is called the pure imaginary numbers. So example, so the square root of -81, just factor or split it, it becomes the square root of 81 times the square root of -1. So the answer is 9i. Definition of equal complex numbers: so two complex numbers are equal if their real parts are equal and their imaginary parts are equal. If e plus bi is equal to c plus di, then a is equal to c and b is equal to d. So when adding or subtracting complex numbers, combine like terms. So in this example, we are using addition. So the quantity of 8 minus 3i plus the quantity of 2 plus 5i. So combine like terms, 8 plus 2 is equal to 10, and -3i plus 5i is equal to 2i. So the answer is 10 plus 2i. Solving quadratic function with complex numbers: so x to the power of 2 plus 2 is equal to -12. So subtract 2, so the answer is x to the power of 2 is equal to -14. So to find x, we have to take the square root of both sides. So the square root of x to the power of 2 is equal to the square root of -14. So the answer is x is equal to the square root of -14. So we have to factor and or split it. So the answer is, it becomes the square root of -1 times the square root of 14. So the answer is I, the square root of 14. Multiplying complex numbers: so to multiply complex numbers, you use the same procedure as multiplying polynomials. So simplify. So the quantity of 8 plus 5i times the quantity of 2 minus 3i. So we have to apply the FOIL method. So 8 times 2 is equal to 16. 8 times -3i is equal to -24i. 5i times 2 is equal to 10i, and 5i times -3i is equal to -15i to the power of 2. So since -24i plus 10i the same variables, so we have to add it. So -24i plus 10i is equal to -14i. So kung nag-wonder ka mo kung hagi ka ng positive 15, so it becomes from I to the power of 2, since the value of I to the power of 2 is -1, so -15 times -1 is equal to positive 15. So 16 minus 14i plus 15 is equal to 31 minus 14i. Conjugate: so each imaginary unit has a conjugate. So two imaginary units are conjugate, so if and only if their products are real numbers. So 3i becomes -3i, 2 plus 4i becomes 2 minus 4i, and -2i becomes positive 2i. So dividing complex numbers: to divide complex numbers, you must multiply the numerator and denominator by the conjugate of the denominator. So 4i over 2 minus I. So what is the conjugate of the denominator? So the conjugate of the denominator is 2 plus I. So we have first to multiply the upper part. So 4i times 2 equals to 8i. 4i times I is equal to 4i to the power of 2. Next, we have to solve the lower. We have to multiply the lower part. So 2 times 2 is equals to 4. 2 times I equals to 2i. Negative I times 2 equals to negative 2i. And negative I times I equals to negative I to the power of 2. So 8i plus 4i to the power of 2 is equal to 8i negative 4, because the value I squared is negative 1. So negative 1 times 4 is equal to negative 4. Then the lower part is 4 minus 2i plus 2i minus I to the power of 2, since negative 2i plus 2i is cancelled. So the remaining value is 4 minus I to the power of 2. So the value of I to the power of 2 is negative 1. So 4 minus the quantity of negative 1 is equal to 5. So any clarification and question? If none, thank you for listening.